All right, this is lesson 6.5. Today we're talking about rational functions. So the difference between a rational function and a polynomial is if you look at like number 1 and number 2 here, you've got stuff in the denominator. You've got x's in the denominator. Remember those rules to be a polynomial, like you can't have variables down in the denominator, can't have negative exponents, can't have rational exponents. So we've got ourselves some rational functions here. And we're going to start out small with number 1 and number 2. We're trying to get all the information we can from this without having to use a graphing calculator, because honestly the graphing calculator is going to fail us on a lot of the weird things that happen. So there's going to be some asymptotes that happen. This chart here at the top, I will be very nice to you and tell you that this chart will be on the tests also. It will not be there for your final exam though. So you do kind of have to get this information memorized for the final exam. But for this test, I will give you this chart. The thing is, can you read it? So we're talking about vertical asymptotes, horizontal asymptotes, and something new to a lot of you, oblique asymptotes, where some of you have seen them if you've taken FST, some of you have not seen them at all. So one thing at a time, the easiest one to deal with is if there's any vertical asymptotes. Those are values of x that make the denominator 0. Because you can't divide by 0. Maybe that's against the rules. So anything that makes the denominator 0 would be bad. So let's look at number 1 here. All we care about for vertical asymptotes is the little expression in the denominator. Is there a value of x that will make this 0 in the denominator? Yeah, -1, right? So that's where our vertical asymptote is at. It'll be at x equals -1. It's a line, right? So it's the vertical line, x equals -1. All you're doing to find vertical asymptotes is looking at the denominator and seeing what values of x make him 0. We cool with that? If you want to put some notes off to the side, well, I guess I kind of typed it for you right here. It's values of x that make the denominator 0. Cool. Now it's brain time, and we have to see if there's any horizontal asymptotes. Sometimes there are horizontal asymptotes, sometimes there are not horizontal asymptotes. So there's 3 things to kind of look for horizontal asymptotes. There will be no horizontal asymptotes if the degree of the numerator is greater than the degree of the denominator. So let's check this out. What is the degree of my numerator here? Degree of the numerator is 1. Degree of the denominator is 1. So is the degree of the numerator greater than the degree of the denominator in this particular case? No, it's not. So then I look to see the second choice. I could have a horizontal asymptote at the line y equals 0 if the degree of the numerator is less than the degree of the denominator. Is that happening here? Is the degree of the numerator less than the degree of the denominator? No, it's not. Right, so I don't have this happening for me either. So I look to see if this is happening. It's very kind of complicated here. Let's just kind of look at what the requirements are. The degree of the numerator is actually equal to the degree of the denominator. Isn't that happening here? Degree of the numerator is 1. Degree of the denominator is 1, right? So that's happening. So your horizontal asymptote will be at this particular weirdo equation right here. It'll be at y equals, and then it says take the leading coefficient of your numerator and put it over the leading coefficient of your denominator. Hence that really easy day we had about recognizing leading coefficients, realizing degrees and all that stuff. What is the leading coefficient of my numerator? It's 1, right? Because it doesn't matter who comes first. It's the highest degree term. Would you agree that this term's got degree 1 and this term has degree 0? There's no x's with it at all. So I've got 1 over, what's the leading coefficient of my denominator? 1. I've got 1 over 1, which reduces to plain old 1. Let me explain that one more time. I was trying to check for horizontal asymptotes. I used this little chart right here. Checked out my degrees. That's what all 3 of these rules have to do with, is what's the degree of the numerator versus what's the degree of the denominator. And it turned out that this was the scenario. The degrees were equal to each other. So it said, all right, your equation is going to be y equals whatever your leading coefficient of your numerator is over the leading coefficient of your denominator. Does that sound cool with you, how I figured that out? Then the last thing to check for, are there any oblique asymptotes? Here's the rules for oblique asymptotes. It only happens in one case. if the degree of the numerator is exactly 1 more than the degree of the denominator. Is that happening here? Degree of the numerator is 1, degree of the denominator is 1. Is the degree of the numerator 1 more than it? No. They are the same, right? Like you're looking for an example of something like this. Isn't the degree of the numerator 2 and the degree of the denominator is 1? Isn't the degree 1 bigger than it, right? So there is none in this situation. None. There were no oblique asymptotes because the degree of the top has to be 1 more than the degree of the bottom for that to happen. Okay? Very, very, very lots of information. That's not a really good sentence, but that's very lots of information. Hence, why you're going to have this chart on the test. Cool? But we want to get comfortable with it before we actually deal with it. So let's try again. Vertical asymptotes. Again, that's what makes the denominator 0. Oh, crap, Batman. That's a quadratic expression. The easiest way for you to know how to make that 0, you got 3 choices. Factor it, complete the square on it, or do the quadratic formula. That's what you've been doing for like 3 years now of trying to solve a quadratic equation, like where it equals 0 is by factoring, complete the square, or by quadratic formula. I'd like to factor first if possible. Let's see if it's possible. When this is a 1, that's an easy scenario. Can you find 2 numbers that multiply together to be negative 10 and add together to be a positive 3? 2 and 5, right? And which one of those has to be negative? The 2. So what I will do is I will rewrite this entire rational expression over again. But I am totally going to change this, because doesn't it factor to be x minus 2 times x plus 5? Is everybody cool with, I just changed this to be that. Those are equivalent. That's what factoring is. This is the point of factoring. Finally, you're kind of going to start to see, okay, is there a use for this? You might not like it, but yes, there is a good use for this. Is that all right with you, what I've done? What's so great about this is now I can figure out the values of x that make the denominator 0. What value of x would make that dude 0 right there? If x was 2. That means that there's a vertical asymptote at x equals 2. And shouldn't there be one more vertical asymptote? Where is the other vertical asymptote at? Don't just say negative 5. You have to write the equation, x equals negative 5. Does that make sense to you how I figured those out? I used factoring, which I know you love, but it's better than doing the quadratic formula. It's faster, faster, faster. Coop, horizontal asymptote. Got to check. It's all about the degree. The degree of the numerator greater than the degree of the denominator. Is that happening? What is the degree of the numerator? Is 0, right? Because there's no x's up there whatsoever, right? And the degree of the denominator is a 2. Is everybody okay with that? So, is the degree of the numerator greater than the degree of the denominator? Yes or no? This is a 0. This is a 2, right? So, not happening. Does that make sense? Like people are like, isn't that a 4? Yes, it is the number 4, but the degree of that is 0 because it's like 4x to the 0th power is what's really going on there. With me on that? So that didn't happen. Is the degree of the numerator, is the degree of the numerator less than the degree of the denominator? That is happening, right? This is a 0. 0 is less than 2, so this tells you where your horizontal asymptote is at. It is at y equals 0. It is at y equals 0. And then you check, is there an oblique asymptote? Here's the rules for oblique asymptote. The degree of the numerator has to be exactly 1 more than the degree of the denominator. What do you think? Is there an oblique asymptote? There is none. I'll give you a secret. Can't have both of them at the same time. If you've got horizontal asymptotes, you can't have an oblique asymptote. If you've got oblique asymptotes, you can't have horizontal asymptotes. It doesn't work that way because when do you get none? If the degree of the numerator is greater than the degree of the denominator, that's kind of like this category. But if that was a 4 and this was a 1, there still wouldn't be any oblique asymptotes because it's not exactly 1 bigger than that. So that was like a little setup, a little warm-up before we actually start making a graph of these without even really using our graphing calculator, sort of, kind of. All right, so let's see if we can fill out these three things right here. Vertical asymptote. Question is, does anything really need to be factored here? This has got some x squared. Doesn't really need to be factored, though, because it's just x squared, right? There's no other stuff with it. This is linear, right? It's all to the first power, so you don't need to factor anything. Do you know a value of x that would make the denominator 0? X equals 2. To me, those are the easiest parts of all of this, finding the vertical asymptotes. What makes the denominator 0? Determine about horizontal asymptotes. Do you have none? Is it at y equals 0? Or do I have to do a little bit of work here? What is the case here? Due to the fact that this degree is 2 and this degree is 1, there should be none, because doesn't that fit into this category right here? So there is none. Oblique asymptotes. Let's see if there are any first, because we haven't even figured out how to find them, but you just have to figure out if there are any. The only way that there are oblique asymptotes is if the degree of the numerator is exactly a 1 bigger than the degree of the denominator. Is that happening? It is. This is degree 2. This is degree 1. Is everybody cool with that? So now how do you find it? You do synthetic division. And it's actually much easier than you think. You're going to divide. The numerator is green divided by the denominator. So, but we're going to do synthetic division. Here's your denominator. We kind of did it last time. You know, like when you want to synthetically divide by x minus 2, you need to divide by the value of x that makes that 0. Should I synthetically divide by 2 or negative 2? 2. Like that, what makes him 0? So I'm going to do a little synthetic division here by 2, off to the side. This is how I'm finding the equation of my oblique asymptote. I need to synthetically divide by 2, and then this guy, the numerator, I'm going to just throw all his coefficients in there. Well, it's a squared, right? It's second degree, so 1x squared, 0x to the first, and 0 constants. Right? If that's got degree 2, shouldn't you put 3 boys in there, right? So that's why I had to put those other zeros. With me? Just trying to make it slow so we see what's going on. Now let's synthetically divide. 1 comes down. That'd be a 2. 2 comes down. That'd give you a 4. And you'd get remainder 4. The remainder means nothing to us, right? It even tells you right here, please ignore the remainder. Who cares what you get? The equation of your vertical asymptote will be oblique asymptote will be y equals. Now, can you go back and tell me what this was? This was a second degree polynomial. Shouldn't it knock it down to a first degree polynomial? So who is this right here? 1x, right? And this is a positive 2. So there's your equation right there. It's that 1x plus 2. That is the equation of the oblique asymptote. Y equals whatever you get from synthetic division. Sound okay with that? Good deal? Woo! Okay, feeling comfortable. We've done 3 of those. Now some new information. X-intercepts. Let y equal 0. Back into this original function, right? Anytime you want to find the x-intercept, you're going to let y equal 0. Well, let me just erase this. You can keep yours, but I'll erase this. I really got this. Sorry. 0 equals x squared over x minus 2. See this f of x? It's the same thing as y, right? I'm going to let y equal 0. And what I want to do is solve for x. I want to solve for x. So I don't care what this is. I would probably multiply both sides by that denominator first to clear the fractions, right? So if I multiply both sides by x minus 2, just watch this. Those cancel out, right? And what's 0 times anything? It's 0, right? So you're left with this. 0 equals x squared. Cool? That will happen to you every time. When you want to find your x-intercepts, it will always be let who equal 0? Who was this? The numerator or the denominator? Who was this? all you care about is where the numerator is 0. Because you're putting 0 in for y, you're going to multiply both sides by the denominator to clear that crap out of the way, and 0 times that denominator is still nothing, right? That will happen every time. So notes off to the side to find the x-intercept, let numerator equal 0. Let the numerator equal 0. Somewhere off to the side to find x-intercepts, all we got to do is let the numerator equal 0. Rock on? So here it is. There's my equation. 0 equals x squared. Wouldn't you square root both sides? And what would that equal? 0. Right? X equals 0. We're just going to say 0 is the x-intercept. Rock on? If you want to write it as an ordered pair, it'd be 0 and wasn't the y value 0 also. But I'll be cool if you just put 0 for the x-intercept. Nice. So notes off to the side because it is overwhelming today. It's just a lot of information coming at you at once. Rock on? Y-intercept. How do you find a y-intercept? You let x equal 0, baby. You let x equal 0. So we'll put that note off to the side. Let x equal 0. Let x equal 0. Easier than you think. It just takes a little bit of practice. If you let x equal 0, go back to the original guy, put 0 in for this, what do you get? 0 over, if you put 0 in for x, wouldn't you get a negative 2 out of that denominator? Right? All I did was substitute 0 in for x. And I've got this fraction right here. What is 0 divided by negative 2, my friends? Is 0. Y-intercept is at 0. So notes off to the side because it's confusing. It's too much information. And these I will not have provided for you. Only thing provided for you is this chart about how to find all these asymptotes. Right? You've got to remember how to find your x-intercepts and y-intercepts. But after we do a few examples, it'll get easier. And now it's time, before we do the domain thing, let's actually make a sketch of this dude. Cool? So the way to make a sketch is first take this bad boy and correctly punch him into your calculator. The way to correctly do that, my friends, is man, oh man, oh man, anytime you've got more than one term in either the numerator or the denominator, you better put parentheses around that. Right? You better put parentheses around that. So I have all of these punched in my calculator. Please don't be alarmed with all this stuff that I have in here. Here's the first one that I have. X squared divided by x minus 2. If you want to put parentheses around the x squared, you can, but it's only one term in the numerator. You really don't have to do that. Is everybody cool with typing that in? Let's zoom 6 it and see what we see. Hope you see that. Do you see that? Let's see if it kind of matches our information here. The calculator does a horrible job of showing stuff like asymptotes and even holes in the graph, which we haven't talked about yet. But vertical asymptote at x equals 2. Would you agree that something weird is going on right here at x equals 2? Cool. And you see something new is happening to us. It's got an oblique asymptote right here. Like this line, y equals x plus 2, like the graph is getting closer and closer and closer but never touching it. Cool? So the first question I have for you is, do we see enough with the standard window? And I'm just going to say yes. We see the graph. It's got 2 branches. I see them both. So let's do that on our sketch. Let's go 10s all around. I've even put some nice little grid marks to help us. Let's take our straight edge and let's go dead center and put our x and y axis. And we said 10s all around was good for us. These graphing calculator sketches with the grids in there, just a little more accurate, especially when you got to graph oblique asymptotes. It's so hard to do without the grids behind you. So do not assume that every one of these problems is going to be dead center and fit in the standard window. Do not get ahead of yourself. All right, you got to take it one problem at a time. Y'all cool with that? First thing you graph, like on our sketch, is the asymptotes as dashed information. So let's start with our vertical asymptote. Isn't there a vertical asymptote at x equals 2? take a wild guess what this is counting by. If there's 1, 2, 3, 4, 5 spots available and I went up to 10, what are we really counting by? 2's. So x equals 2, isn't that right here, baby? Right here. And you will label him on your graph VA colon x equals 2. There is a vertical asymptote right there at x equals 2. Cool with that. There is an oblique asymptote. Folks, if you don't know how to graph an oblique line, you don't deserve to be in college algebra. It's not that hard. This is in slope-intercept form. What is the y-intercept, my friends? 2. So isn't that right here? Correct? And the slope is 1, right? Which could possibly be like rise 2, run 2. Isn't that also possible, like 2 over 2? If I wanted to go up 2 units, which is, and over 2 units, isn't that really like a slope of 1 right there? Rise 2, run 2, rise 2, run 2. You see what I was doing with up 2 to the right 2, because the scale is counting by 2's, not 1's. Take your straight edge and connect those together as a dashed line also. All asymptotes are dashed. Then you'll put an OA, y equals x plus 2. That is an oblique line with a slope of 1 and a y-intercept of 2. Good deal? X-intercept, we're going to plot him next. He's at 0. 0, 0. There is an x-intercept there. There's also a y-intercept there. It's the same place, right? 0, 0 crosses the x-axis, crosses the y-axis. Is there any other bits of information here that I need to put on my sketch? We have taken care of him. He didn't exist. We have taken care of him. We have taken care of him. And we have taken care of him. Correct? It is now time to do a nice little freehand of the old information. So grab your pencil and pick a, sorry, I just wanted to switch colors there. So I'm going to make this branch in here. It just kind of has to hug this asymptote a little bit, and it will touch that point right there and come on down and hug that asymptote a little bit. And same thing up here. That's a freehand in my opinion. You could get more accurate with it, then take FST if you want to. But for college algebra purposes, let the calculator do the rest. Notice I did not cross up and over and intersect it anywhere. It's like that is the only place where this little branch will cross the x-axis or y-axis. Cool? Please highlight that with your highlighter. The actual graph itself, once you've got it sketched, highlight it. It makes it easier for me to grade. Do not highlight the asymptotes, just the graph itself. Actually, I changed my mind. Pick a different color and highlight the asymptotes. We did that last year, and it was really easy. Second color, highlight the asymptotes. Q. Now it's back down to the domain. And honestly, the domain could be done without the sketch or without the calculator, because this is really the information that we care about. This is telling you bad zones, right? There's a vertical asymptote at x equals 2. That means x can never be 2, right? That's a bad, bad place. So if you took your straight edge and you kind of started way over here, and you just want to know, would either one of these green branches that I have touch it over here at negative infinity? Would that happen? Yes or no? The answer is yes. Negative infinity. Right? Negative infinity is good. That branch right there touches my straight edge. Cool? I'm going to keep going this way. Touching, 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 until I get to where? Until I get to that asymptote. So sorry, people in video land, I was just moving my straight edge this way. It was touching, 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 until I get to 2 right there. I think I said negative 2. I'm sorry I said that. But until I get to 2, right? 2 is a bad place. So that's where I'm going to put my next critical point. It cannot actually be 2, so should I put a bracket or a parenthesis there? Parenthesis. Then I'm going to start a whole new interval, because I've got more parts to my graph right here. Doesn't it totally start over again at 2? right? And it's a hard little branch to see, but that thing's going to keep going forever and ever and ever to the right. And how do I know that? Because there's no more vertical asymptotes. The only crazy thing that happened so far was this 2 was the only bad number. Sound all right with that? Let's try another one. Woo! Let's look at the actual function and see if I need to do some factoring. Do I need to do some factoring? Yes, in the denominator. Please find 2 numbers that multiply together to be 5 and add together to be 6. Those are 1 and 5, right? So this guy will factor to be x plus 1 times x plus 5. Is everybody cool with the factoring of the denominator? What's so great about that? He tells you some things. I want you to notice, though, now we've got that new weird thing that I was talking about. Something really, 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 really weird is going to happen. Do you see? You have the same quantity upstairs and downstairs at the same time. That's going to cause what's called a hole in the graph, right? We'll get there when we get there, but that's the new thing that's going to happen. It didn't happen back here. I didn't have the same quantity upstairs and downstairs, right? I didn't have it. I do have it here. When I factored, I saw, hello, I've got myself a weird scenario. So let's talk vertical asymptotes first. This guy has nothing to do with the hole. What value of x makes this 0 right here? If x equaled -5, I'd have a vertical asymptote there. But let's just talk about what would happen if x equaled -1. Because would everyone agree that x equals -1 makes this orange guy down here 0, right? So I'd get this. Just don't write this down, but I'd get this. 0 times 4, because if I put -1 in there, wouldn't that little quantity right there turn out to be 4? What would the numerator turn out to be? 0. And 0 times 4 is how much, my friends? You get 0 over 0, which is a chaotic situation. You can't do 0 over 0. Take calculus, and you'll learn that there's a limit approaching that point, but we're going to call it a hole in the graph. There's a hole in the graph because at this quantity, if I let x equal -1, I get 0 in the numerator and I get 0 in the denominator. Crazy, crazy, crazy situation. So there is no vertical asymptote there, but we will say that there is a hole. So we write down hole at. And I need an ordered pair next. Could you tell me the x value of the hole? Like, what was the x value that gave me 0 over 0? -1 was the bad boy. Right? -1 is the x value. And most of you, after we finish this worksheet, will be pretty comfortable with that. It's like, okay, I've seen that there's going to be a hole, and I know that the x value of it is at -1, because isn't that the number that makes this 0 right here? How do you find the y value? You have to do this. Okay, so let me erase a little bit. Yep, sorry, that's not an eraser. You have to do, that's still not an eraser. You have to say, shoo, shoo. I'm going to cross those out. Don't they like cancel each other out? And here's what you'd be left with. Something downstairs. Don't you have that? Please do this along with me. But what the heck is left upstairs? If this guy is really gone, there's got to be something left up there. What's really left up there? Not 0, it's a 1, right? Because it's like you got 1 times that quantity right there. Y'all cool with that? So how do you find the y value of the hole? You substitute -1 into this expression right here. Let's put -1 in for this. The only place you can put it in is right here, right? So you'd have 1 over, what's -1 plus 5, baby? 4. That's the y value of the hole right there, 1/4. I put -1, which is the x value of that hole, in for x, into the simplified function, because I canceled the quantities that were the same on top of each other. Woo! Deep breath. Let's try something nice. Horizontal asymptotes and vertical asymptotes. Horizontal asymptotes and oblique asymptotes. Please see if there are any. Use the chart. Let's get back comfortable. We've done the vertical asymptote, and there was a hole. Now check those out for me. It is usually easier to look back to the original guy before you factored him because you can see the degrees better. Doesn't this have degree 1 and this have degree 2? Right? So the degree is smaller. So of the numerator, isn't that this scenario right here, where the degree of the numerator is less than the degree of the denominator? So that's at y equals 0, baby. And will we have an oblique asymptote then? Since I had a horizontal asymptote, that answer is none. I like that little shortcut. If you put an answer for horizontal, then the other one is automatically a none. Cool? Unless you put none here, then you have to check. X-intercepts. How are we doing that again? What value of x makes the numerator 0? That would be what in this case? -1. Now, normally, that would be good. Is something crazy happening at -1, though? There's a hole there, right? So since there's a hole, what that means is, let me make it easier for you to understand. Let's go back to Algebra 1. That's 7. If I asked you to graph this, would you know how to graph that? You would put a dot above 5. What kind of dot? Open dot, or what we call a hole, right? There's a hole there, and then you graph this. Like, does 5 actually count in that solution set right there? There's an open dot, which is called a hole in the graph at that point right there. So if I go back here, -1 totally would be the x-intercept, but does -1 count? So there is none, right? None. And if you want to even make yourself a note of why, due to hole. There's none due to the hole. You don't have to put that on the test. All you have to put is none. But if you're looking back at notes, you know, it's like, how come there was none? It should be at -1. There's none due to the hole in the graph. Y-intercepts. Y-intercepts, after we do a few of them, easier than you think. Don't you let x equal 0? Is that right? Let x equal 0. So here's what happens. This is gone. This is gone, and this is gone. Isn't that everything that had an x with it? Correct? They're all gone. And look at what you got left. What do you have left? 1/5, right? Isn't it 1/5, right? If x was 0, all that stuff would be gone, and you got 1/5 right there. 1/5 is the y-intercept. Good deal? Time to make a graph of this. Before I even attempt to start drawing things, I want to actually graph it in my calculator to see what it's supposed to look like. Make sure you use parentheses in both the numerator and the denominator. I would just type the original guy back in. It's up to you. It really doesn't matter, but I like the original guy. Parentheses, parentheses. Anytime there's more than one term, you got to put it in parentheses. Then graph that old boy. Oh, I did clear that guy out. Sorry. Clear out my old one. Graph. Is this what yours looks like? Let's check, double check that we have it typed in, because some of you are looking at it funny. X plus 1 in parentheses divided by the parentheses x squared plus 6x plus 5, close them up. Right? So let's see. What's supposed to happen is all of this information. I'm supposed to have a vertical asymptote at x equals -5. Does it look like that's happening? So let's realize that I think that the Zoom 6 window is fine for this. I see everything that I'm supposed to see, right? So let's start setting it up. Centered and centered. 10s all around. 10, 10, -10, -10. Those are just my x and y axis. They do not get highlighted. Next thing I want to graph is all my asymptotes. I have an asymptote at x equals -5. So again, the scale is counting by 2s, right? The scale's going by 2s. So you kind of got to split the difference here. This is 2, 4, 5. Right in the dead center of that bad boy. There's a vertical asymptote at x equals negative 5. We can put the whole also, right? Because I just like to start graphing things from here on down. I've graphed this. I got to graph the whole. He is at negative 1, 1/4. So negative 1 is like right here, 1/4 right here. I'm going to put a hole there. I put an ordered pair, negative 1, 1/4. I just put an open dot basically, you know? Open dot. Cool. I have graphed him. Now, I got a horizontal asymptote. At y equals 0, I will graph him. Yes, I want you to graph him. You can at least highlight, you know, like you already have it over there, but you have to put horizontal asymptote at y equals 0, and you'll highlight him, the color of your asymptotes. Both of your asymptotes should be the same color, and dashed. So horizontal asymptote at y equals 0. Oblique asymptotes, there are none. X-intercepts, this guy will have none. None, none, none. It will not cross the x-axis. That's what that horizontal asymptote at y equals 0 is doing. There is a y-intercept at 1/5. So that's when x was 0, right? If you like the ordered pair, you can put it there. But the y-intercept is 1/5. So 0, 1/5. So that's like there. 0, 1/5. Excellent. And isn't that all the bits of information that I have right there? So going back to the calculator one more time to see what this bad boy should look like. I've got a branch over here that is getting closer and closer and closer to the asymptotes. So let me use green, sorry. Something like this. My pen got lifted, sorry. Good deal. And that same concept coming up this way, and it should go through these 2 points, but don't fill in your hole. So I'm going to do this. It's getting closer and closer this way, and then this. There is a big old hole in the graph. Make sure that thing is visible for me to see that you put a big old hole there in the graph at x equals negative 1. Then highlight your actual branches. Woo! Finally, domain. This entire blank has to do with your domain of the function. That blank tells you who x can't equal. The graph can help you a little bit. If I start way over here at negative infinity, doesn't this graph go to it? Right? Negative infinity. So from negative infinity, work my way to the right, to the right, to the right. Where is the first critical point where this graph will not have an x value? At negative 5, right? And it will not be included. Cool. Start over. Again, at negative 5, it will start over, but it's way up here at positive infinity, and it's starting to work to the right. Is there any critical places of an x value that's just not going to work? Negative 1, right? It's the x value of your whole, so it goes from negative 5 to negative 1. And negative 1's got a parenthesis because it doesn't count. And then we got a whole other thing to start over with. Doesn't the graph start over at negative 1 again? And then it just keeps going to positive infinity. So again, these are the 2 points that were critical in your domain. Negative 5, so you got to split it up right there. And negative 1, so you got to split your domain up there. From negative infinity to infinity, you just got to split him a couple times. Okay, let's try another one. I've got the rules up top on the screen if you want to look at them. Let's see if I need to do any factoring before I get started, though. Before I turn you loose, let's talk about the numerator. First, can the numerator factor? Well, it's possible. You see some x squareds in there. Does it have x to the first in there also? No. Remember the old GCF concept, though. It's like, is there a GCF that could be factored out of this at all? The answer is no. So your numerator is going to stay 3x squared minus 2. Good deal? Denominator, very possibly can factor. There's x squared and x to the first. Please try to factor the denominator. Two numbers that multiply together to be negative 12 and add together to be 1. That would be negative 3 and 4, right? So x minus 3 times x plus 4. Y'all cool with me factoring that? Before I turn you loose, my question to you is, will this guy have holes in him? Do you see the same quantity upstairs and downstairs? Here's an x minus 3. Is there an x minus 3 up there? Nope. Here's an x plus 4. There is not an x plus 4 up there. No holes in the graph. Cool? Only time you get holes is when you've got the same thing up and down. Rock on. Please do the 3 asymptotes with your pal. Okay. Everybody cool with the vertical asymptotes, right? And I bet you realize what kind of asymptote we have next. Is it going to be horizontal or oblique? What kind of asymptote should I have? I should have a horizontal asymptote because would you agree that the degrees are equal to each other, right? And then you're wondering, okay, how did we do that again? How did we do that? Leading coefficients, right? Who is the leading? So it's going to be at y equals, sorry. It's going to be at y equals leading coefficients over each other as a fraction. Who's the leading coefficient of your numerator? Again, look back to the original guy before you factored it. It's easier. It's going to be what? 3 over leading coefficient of the denominator, which is 1, which you just plain old change to y equals 3, right? 3 over 1, which is 3. So because they were equal degrees, it's the leading coefficients. This 3 and that 1 right there. All good with that. Is there any oblique asymptotes then? No. If this has horizontals, then there is a none. All right. X-intercepts. What happened? What do you do for x-intercepts again? Where the numerator equals 0, right? So find yourself a little bit of room for scratch because the numerator is very complicated, right? It is a complicated numerator. I'm going to find myself some scratch work and say, I would like 3x squared minus 2. That is the numerator. I'm going to set him equal to 0 and solve for x. Cool. First move to solve for x would be what? Add 2. 3x squared equals 2, right? Divide by 3, x squared equals 2/3. Nice? Then what you got to do? Square root both sides. So x equals plus or minus square root of 2 over the square root of 3. You could square root the whole thing, but you probably remember you can't have a radical in the denominator of a fraction, right? So I separated it out right away. And now, what do I need to multiply this by to get rid of the radical in the denominator? Radical 2 over radical 2 or radical 3 over radical 3? Radical 3 over radical 3. So just leave that plus or minus coming along for the ride. We've got to multiply by radical 3 over radical 3. Remember that? It's been a while. Radical 2 times radical 3, you could totally multiply radicals together. Radical 2 times radical 3 is radical 6. Radical 3 times radical 3 is really radical 9. But radical 9 is like the square root of 9, which is how much? It's 3. That's the whole reason why we did that. We should not get a radical back. And don't forget, we've got the plus or minus in front of it. So our x-intercepts are at square root of 6 over 3, comma, negative square root of 6 over 3. There are two of them, the plus or the minus. Start over. How the hell did I do that? I set the numerator equal to 0. And it wasn't very nice. Right? So I just had to go off to the side where I had some room to do some algebra. And I had an even worse scenario. I got a radical in the denominator. But you just let the numerator equal 0. Cool? Deep breath. Y-intercepts. Let x equal 0. Say goodbye to him, and goodbye to him. Look at what's left over. What do you got for leftovers? Negative 2 over negative 12, which reduces to what? Positive 1 over 6. That's the easier one. Like way better. You let x equal 0 to find a y-intercept, so anywhere there is an x, that will like turn into a 0. That's why I just scratch them out. Cool? If you scratched everything out from the numerator, though, if everything was scratched out, there's really a 1 there. Right? It just doesn't completely disappear. There's really a 1 there. Okie dokie. All right, I take that back. It would be 0. I take that back. That's my fault. If you scratched everything out, because there was an x there, you would have a 0 upstairs. That's my fault. Let's make a graph of this bad boy. Yes. Deep breath. Deep, deep, deep breath. Mr. Crazy Town. Crazy Town graph. 3 different branches. We can start, after we do a bunch of these, start using a little bit of some sense. I could probably tell you that there had to be 3 branches based off the fact that I had how many vertical asymptotes. So like there's 2 asymptotes cutting through this. Doesn't that separate into 3 little zones right there? Right? So how about the Zoom 6 window though? Do we see what we want to see? I think so. So let's start with that. Again, that might not always be the case. Most of the time. We're trying not to give you the most complicated ones in the world here. And then let's put our asymptotes in there. No holes. That's cool. Let's draw all our asymptotes in there. So you've got some vertical asymptotes at x equals 3. That's not what I wanted to do. I'll let you draw them in. You can do it. X equals 3, so this is 2, 3. VA, x equals 3. I got another one at x equals negative 4. I'm just going from the top of my work blanks here down, just graphing everything that I possibly can. I have graphed both vertical asymptotes. I have a horizontal asymptote at y equals 3. I will graph him. So 2, 3. Got my horizontal asymptote there at y equals 3. Right? I got him. Now I'm going to start putting these x-intercepts and y-intercepts. You can punch those in your calculator to approximate them as a decimal. Like what is the square root of 3 divided by, or square root of 6 divided by 3? So second square root of 6. Close that up. Divided by 3. It's like 0.8 basically. So I will plot him. And let's see, this is 2, this is 1, so about like right there. But I'm going to put him at square root of 6 over 3, 0. Right, that's one of my x-intercepts. I got another x-intercept right here at negative square root of 6, 0. Oh, it's next square root of 6 over 3, sorry, over 3, 0. Again, I punched them in my calculator to see what they were as a decimal. And then y-intercept of 1/6, that's really, really tiny. So that's like right here. 0, 1/6. And that is everything on my list that I need to plot. I will then let my calculator show me what the rest of this should look like. So I know this old branch right here is going through this information, then gets closer to those asymptotes. So I make him. And he's just got to go through those three places, the y-intercepts and the x-intercepts. And then these two branches went something like this. And I'll highlight those. Last thing is domain. I've got these 2 points right here that are bad zones for my domain, and the graph will kind of let me find that domain. You will go from negative infinity, right? He's totally hitting it, right? You got that branch there, all the way up to that very first vertical asymptote of -4. And they never count, duh, they're asymptotes. You'd start over at -4 again. So you're on this green branch down here, right? It's all good in this zone, right? Isn't there a graph in that zone? So you'd go from -4 all the way up to where? 3. And then you'd start completely over again at 3 and go to infinity. After doing enough of those, you could totally do the domain without having to see the graph, because it's just those either holes in the graph or vertical asymptotes. Okay? Yeah. We're going to skip number 6 and go to number 7. Do I have any factoring that needs to be done before I get started? I could factor the numerator. Hopefully, maybe. Let's try to factor the numerator. Two and 5, right? Then the first question you ask yourself after you get them factored, any holes? Any holes in this graph where you got the same quantity up and down? No holes. Asymptote me. Give me the 3 bits of information for the asymptotes. Is there a vertical asymptote? Where at? X equals -1. Horizontal asymptotes, I got to check the degree. This degree is 2. This degree is 1. Right? The degree of the numerator is bigger than the degree of the denominator. That's this category right here. So that means that there are none. Everybody down with that? The degree of the numerator was 2. The degree of the denominator was 1. Greater than? None. I know that might be hard for you to read from a distance. Is there an oblique asymptote? Is the degree of the numerator 1 more than the degree of the denominator? Yes. It's time for synthetic division. Let's find ourselves a little spot to do some synthetic division. Who do you synthetically divide by? -1 in this case. And I will put him in here coefficient-wise, 1, 7, 10. All right, 1, 7, 10. Let's do some synthetic division. 1 comes down. That'd be -1. 6 comes down. -6. 4. Nobody cares about that remainder. Nobody cares about the remainder. Who is the oblique asymptote? Don't forget y equals x plus 6. This is the x, and this is the 6. Rock on. X-intercepts. X-intercepts. That's probably the weirdest of all of these. Since you have the chart for the asymptotes, it's not that big of a deal. X-intercept. That's when you let who equal 0? Numerator. Hey, I'm going to use this side, right? When the numerator equals 0, I want to know what x would be. That's why that factored version right there. What values of x make this guy 0? -2 and -5. There's your x-intercepts right there. -2 and -5. It's like if you set that numerator equal to 0, totally solve it. Please find the y-intercept for me. Let x equal 0 in the original guy. Y-intercept of 10. Good deal. Let's graph him and see what he looks like. Don't forget your parentheses. Zoom 6 going to work for us. Do I see enough of that other branch? Got to change it. Got to change that. So who has to change out of x min, x max, y min, y max? Who's got to change? Y max. And I'll probably change the y min also. I'll make my y min go to, like, say, -6 instead, and my y max. It'd be easy for you to choose an even number instead of an odd number due to the fact that we've usually been counting by 2's on this guy, you know, like the way the grid marks are. So I'm going to try 14. You know, most people probably would have went to 15 because we like to count by 5's, but I want an even number. So let's see if we see what we want to see. That's enough of that other branch right there. Cool? So let's see here. If I start here at -6, then this is -4, this is -2, and isn't this guy right here 0, right, since I'm actually counting up? So I'm going to just count from the bottom to the top. Since I said that was -6, this is -4, this is -2, that's 0, there's my x-axis. And the y-axis I had him centered. 2, 4, 6, 8, 10, 12, 14. I made it. Window parameters, 14, 10, -6, -10. Asymptotes, next. X equals -1. Use a different color, please. And I've got an oblique asymptote. So I got to be careful about this. I got to start at 6. So here's 2, 4, 6. And my slope is 1, so I can just go on the grid marks, because that's like rising 2 and running 2. And then I'll label him also OA, 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 y equals x plus 6. I've graphed him. Didn't have to graph him. Graphed him. X-intercepts and y-intercepts are left. X-intercept at -2. So -2, 0. Cool. And at -5, so 2, 4, 5. If it hits your line a little bit, it really isn't going to. Just put it a little off to the right. You know, it's just a sketch. It's not the most accurate thing in the world. Y-intercept of 10. So 2, 4, 6, 8, 10, 0, 10. After I have all that, it's time to make the sketch. Let your calculator show you what it's supposed to look like again. You can do it. Make the sketch. It's going to get closer and closer to that asymptote. It's going to come up and over, come down. That's why there's intercepts there, right? It totally intercepted at -5, came up, and came back down. There's a turning point there, if you want to call it that. And follow the intercepts. They're like yellow brick roads, folks. I meant asymptotes. Follow the asymptotes. Get your domain. There's only one bad guy because there's no holes, so you don't even really need the graph anymore, in my opinion. There it was. Only one bad boy, -1. Yes, 1 mo. 1 mo. Oh boy. We better have ourselves some room. We got some up top where we skipped that problem. We need a factor, and these aren't easy factor. They are frowny face factor. So I'll let you factor the numerator and factor the denominator for me real quick. Please pause the video and get that done. And of course we factored all that correctly and got x minus 2 times 2x plus 3 in the numerator, correct? And x plus 1 and 2x plus 3 in the denominator, because everybody can factor that correctly, right? So the question before you get started, will there be any holes in the graph? Yes. So we're going to start with him. Hole. At. Leave yourself room for the other vertical asymptotes, but there will be a hole. At. The question is, what value of x makes that 0? It's the same old trick as opposite of this guy over that guy that we've been doing. What value of x makes that pink thing 0, my friends? You can do it. You can do it, right? Opposite of this guy over that guy. What is it? Negative 3/2. Right, there is a hole at negative 3/2. Now we have to find the y value. So what do you do to find that? You totally cancel those guys out and you look at this guy. Right, if you got rid of the 2x plus 3 over the 2x plus 3, I want to put negative 3/2 in there. Or negative 1.5. Right? I don't care if you switch it to a decimal in math and enter it. So do that. Use negative 1.5 and substitute that in for me. I'll bet that's negative 3.5 in the numerator. Right? Isn't negative 1.5 minus 2 negative 3.5? I am putting negative 1.5 in for x. So in the numerator, did you get negative 3.5? Yes or no? Please do them separately. Don't try to treat it like it's just one problem. In the denominator, what if you put negative 1.5 in there? What would you get? Negative 0.5. Now punch that in your calculator and see what it turns out to be. If it's a whole number, awesome. If it's a decimal, math enter it. And it probably turns out to be 7. Is that right? There is a hole at negative 3/2 7. First question I have for you, did you all understand where the negative 3/2 came from? The value of x that makes that dude 0. How do you get to 7? You've got to punch, cancel those out, and put negative 3/2, or if you want, negative 1.5 in for x. And I did that separately. I put it in the numerator, put it in the denominator, and punch that in. Are there any vertical asymptotes? So I got the hole, right? Are there any vertical asymptotes? Are there any vertical asymptotes? X equals negative 1. Whew. Sweet. Horizontal asymptotes. Go back to Mr. Ridge, right? The factored one is good for all your holes and your vertical asymptotes. Go back to the ridge. Everything you're looking for has to do with degree now, right? Who's the degree of the numerator? 2. Who's the degree of the denominator? 2. Same. 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 So you try this. Leading coefficient over leading coefficient for me. It'll be at y equals leading coefficient over leading coefficient, which would be 2 over 2, right? Which we usually call 1. Will there be an oblique asymptote? Nah. Lovely? You don't have to like it. Are we at least kind of understanding what's going on? X-intercepts. That's where you let what? Numerator equals 0. 2 places, right? We use the factored form for that. At x equals 2 and x equals negative 3/2. Do both of those count? We've got a hole somewhere, right? We've got a hole, so one of those x-intercepts doesn't get a count. It's this one right here. There is an open dot there, so x-intercept of 2. That's it. Give me a y-intercept. Give me a y-intercept. Let x equal 0. So I will say goodbye to you, because that'll be 0. Goodbye to you. That doesn't have an x with him, so I don't want to cross him out. This has an x with him, I'm going to cross him out. This has an x with him, I'm going to cross him out. I'm left with negative 6 over positive 3, which is negative 2. Good deal. Graph him, see what he looks like, so we can make a sketch. Go back to zoom 6, because we changed our window a little bit. Something went wrong. I turned it off, maybe. Yes, I turned it off. Looks like so. Zoom 6 works. Let's put all our asymptotes. 10s all around, so I'll set it up with my norm. Got a vertical asymptote and a hole. You got a vertical asymptote and a hole, so get both of those plotted for me. The hole is at negative 1/2, right? So which side of the asymptote is that on? Like here's this vertical asymptote at x equals negative 1. Is it on the right side or the left side? It's negative 3/2, negative 1.5. Right side or left side? It's on the left side. 2, 4, 6, 7. Hole. Hole. I've got a horizontal asymptote. Got some x-intercepts. X-intercept of 2. Y-intercept of negative 2. That's all, folks. Got my asymptotes, got my hole, got my intercepts. Use the calculator to see what it's supposed to look like. To do the domain, if you weren't looking at the graph, you got to realize that this guy is smaller than this guy, so he's got to come first, right? You go from negative infinity to negative 3/2, union negative 3/2 to negative 1, union negative 1 to infinity. That's it. If you have some questions out there in video land, which I assume you might, come see me and I will help you. Have a good one.